Hello and welcome back. For this video we're going to show you how to solve polynomial equations in factored form. So they're already going to be factored for you, and we'll talk about what factoring is later on in more detail. Right now we're going to talk about the zero product property, and this is why factoring works. The zero product property is pretty simple. If two numbers are being multiplied together and their product is equal to 0, what that means is either A or B or one of those two factors has to be the value of 0. So if A times B equals 0, then that means either A is equal to 0 or B is equal to 0, or possibly both. And it doesn't matter which one equals 0, because when you multiply anything by 0, you get an answer of 0. So we're going to force our equations or our expressions to equal 0, and we're going to solve them. And when we solve them, we call those solutions roots. First example is, suppose this is letter A and this is letter B. So A times B equals 0. So what that means is either x minus 5 is equal to 0 or x minus 1 is equal to 0. And we just end up solving for x in both cases. So over here we're going to add 5 to both sides, and x equals 5. And over here we're going to add 1 to both sides, and x ends up equaling 1. So what that means is if I put a 5 in here or here, this equation will equal 0. Or if I put a 1 in here or here, the equation will still equal 0. So there's actually two solutions here, a 5 or a 1. Next example, 2n minus 5. That whole thing is multiplied by 4n plus 3. So I can call this A, I can call this B, and the whole thing is supposed to equal 0 when multiplied together. Well, that means that this expression is equal to 0. 2n minus 5 equals 0. I'm going to see what value of n caused that to be 0. And this one over here could equal 0. So I'm going to force this expression to equal 0 and see what value of n caused that to happen. So on the left-hand side here, I'm going to add 5 to both sides, and I get 2n equals 5. Then divide by 2 on both sides, and n equals 5 over 2, or 2.5 if you want to call it that. So if I put a 5 over 2 or 2.5 in for n, I will get a 0 answer out. The other option here is 2 minus 3 on both sides on this one. I end up with 4n equal to negative 3. Divide both sides by 4, and I get n equals to negative 3/4, or negative 0.75. So if I put an n of negative 0.75 or 3/4 in either of the original problems, I will get a 0 answer out again. In some cases we have to do what's known as factoring, and what we're going to do now is factor a monomial called the greatest common factor. And factoring is really the undoing of multiplication, it's division. So what you need to do is find the GCF, the greatest common factor. It's kind of like simplifying a fraction. So let's take this one on the left. We look at the coefficients. We got a 12 and we got a 42. And we ask ourselves, what is the greatest number that goes into 12 and 42? So we're going to use a GCF here. And we say that that would be a 6. Okay, well 6 goes into them. And a y and an x are not in common, so the only thing I can actually divide out of both of those is a 6. So what I'm going to do is divide a 6 out of both. So I'm going to bring my 6 on the outside of my parentheses, so I'm undistributing basically. And a 12 divided by 6 gives you 2x, and a 42 divided by 6 gives you a positive 7y. And using the GCF of 6, we've now factored that out into 6 times 2x plus 7y. So when we say factoring, we're asking what did it look like before we distributed the number on the outside, and that's the answer. Over here on the right side, we got to find the GCF for this. And looking at the 4 and the 24, what do they have in common? The greatest common factor. Well, it looks like a 4 in common. But they also have some x's. You notice one has an x to the 4th and one has an x to the 3rd. Well, I can only take out as much as the smallest one has. So we're going to take out a greatest common factor of x to the 3rd. So my greatest common factor of both terms is actually 4x to the 3rd power. So I'm going to take my 4x to the 3rd power on the outside, and I'm going to divide the entire expression by 4x to the 3rd. So the first thing is 4 divided by 4 is going to give us 1. X to the 4th divided by x to the 3rd is going to give us x to the 1st power. Bring down the plus sign. Then 24 divided by 4 is going to give us 6. Then x to the third divided by x to the third is going to give us 1. 1 times 6 is just 6, so I end up with just x plus 6. So my factored form is 4x cubed times x to the first plus 6. Example 3, sometimes we want you to solve for the variable. What variable or what value of s causes this equation to equal 0? And sometimes we have to factor before we can actually solve it. So let's find the GCF of these two numbers. Well, let's look at the 3 and the 9. Well, they have a greatest common factor of 3. And the variables, s to the second and s to the first, take the smaller one, so 3s. So I'm going to factor a 3s outside. If I divide this whole thing by 3s, the first one, 3s squared divided by 3s leaves you with just s to the first. And divide the second one out. Negative 9s over 3s is going to give you a negative 3. Close your parentheses. Still equal to 0. So that was my product before I multiplied it out. Now I have my A and my B scenario, which multiplied together gives us 0. So what does that mean? Either A, in this case, which is 3s equals 0, or B, which is s minus 3 equals 0. And I'm going to solve for both. So on this side, I'm going to divide by 3, so I have s equal to 0 is one option. Over here, I'm going to add 3 to both sides, and I have s equal to 3. So if I put a 0 in place of s, I will get a 0 answer. If I put a 3 in place of s, I will also get a 0 answer. Last example here. 6n squared minus 27n equals 0, so this is another quadratic, and notice it has a power 2, so maybe there's possibly 2 solutions, but in order to solve it I need to factor it first, so I got to find the greatest common factor and look at the 6 and the 27, and that would appear to be a 3. They have a 3 in common. Look at the n's. I have an n to the second and an n to the first. You always take the smaller amount into the third. So 3n appears to be my greatest common factor, so I'm going to divide this whole thing by 3n, and 6n squared divided by 3n is going to give us a positive 2n, and then a negative 27n divided by 3n is going to give us a negative 9, because the n's are going to become a 1, and the whole thing is still going to equal 0. So I'm back to one number times another number equals 0, so one of those two numbers has to have a value 0. So let 3n equal 0. That's my first one. And I can let 2n minus 9 equals 0. So divide by 3 over here, and I get n equals to 0. There's one solution. And over here I'm going to add 9 to both sides. So I have 2n is equal to 9. Divide both sides by 2. And I have n equal to 9 over 2, or I could call it 4.5, and there's another solution. So I have two possible solutions that if I put either of these answers in place of n up here or there, I will end up getting a 0 answer out for the value of the equation.